Hi, my name's Romeo Bruni and welcome to the Astronomy channel. Today we're going to talk about nebulae. Nebulae are vast collections of dust and gas in the interstellar media. Nebulae go through a cycle with stars where great molecular clouds of hydrogen and helium and dust collect and contract and heat up and eventually form stars. The stars create the higher elements and then eventually die. When they die, either into a white dwarf neutron star or a black hole, they emit a large part of their envelope back out into the interstellar media. That's more dust and gas going back out into the media. So you have a constant cycle of stars cycling into gas and dust back into stars. And it goes on infinitum. When we discuss nebulae and classify them, we're basically looking at various stages in this evolution. So we can divide nebulae into three basic types: dark nebulae, H2 nebulae, and supernova and planetary nebulae. Let's go through them one by one. Dark nebulae. Dark nebulae are basically the huge molecular clouds that form. They're cold molecular hydrogen. It's before the stars have formed. So these are the massive megaparsec large molecular clouds of hydrogen, helium, and dust that collect and slowly start to contract. But there's no star formation yet. Because there's a lot of dust and stuff in there, they're dark. They don't emit light, and they actually block the light from stars behind them. So they appear as big black blobs. These are massive molecular clouds just waiting to start to form stars. But no stars in there yet, so they're not emitting light. Dark nebula. H2 nebula. Astronomers have their own quirky way of naming things, and H2 refers to ionized hydrogen. So we're talking about either the H2 molecule and it's lost an electron, or even just a hydrogen proton and with the electron separate, so it's a hydrogen ion. H2 areas are dark nebula that have evolved enough so that now stars have formed within them. And when stars form within them, they start to do various things. The stars that have formed produce very strong solar winds. So the stars that have formed within the dark clouds actually start to blow away the very clouds they were born within. Also, the stars that were born within the dark nebula also then begin to light up the nebula. If light reflects off a nebula, it's actually refracted, and that's why it's blue color. And then that's called a reflection nebula. There we have stars bouncing light off a darker nebula to give you a reflection nebula. If the nebula is close to the stars involved, the nebula, the hydrogen, heats up. When it heats up, it starts to emit light, and therefore it's called an emission spectrum. Because you have various elements in the cloud, you can have various elements contributing to the emission spectrum, like oxygen or nitrogen, or etc. So when the dark nebula get lit up and get hot, they form H2. We call them H2 nebula. Of course, H2 nebula mean star-forming areas because the dark nebula have conglomerated into stars, and the stars are lighting up. So H2 areas are star-forming areas. Of course, one of the most famous H2 area are the pillars of creation. This is one taken by the James Webb telescope. So you see there's very bright stars that have formed up here. They're creating a solar wind that's actually blowing all this back. Stars that have yet to form, but are about to form, are forming in the tips here. And that's why they're glowing very deep red. Those are actually protostars, red protostars, that are still not fully fledged stars in the most dense areas of the pillars. These pillars are approximately 4 light years in length, so they're quite huge, and they're packed with stars. If you look inside, there's lots of little stars being formed in these pillars. If you were to look at through these pillars with the James Webb Telescope in the infrared filters that filter through dust a lot more, you'll see even more stars, because these areas are like packed with stars. H2 areas produce thousands and thousands of stars. So H2 nebula are either reflection nebula or emission nebula, depending on how the light is hitting the nebula involved. Pillars of creation, the most famous in the Eagle Nebula, but of course you've got all sorts of similar H2 nebula distributed around the Milky Way. The third major group of nebulae would be the supernova and planetary nebula. They're more or less the same. Basically, the dark nebula is before the stars form. H2 is during the time the stars are being formed. And when any particular star meets its end, when it dies, if it's under 8 solar masses, when it dies, it'll give off its final puff of envelope in something that we call a planetary nebula. When something is a little bit bigger, if it's between 8 to 18 solar masses, when it dies, it'll become a neutron star, but in the meantime, you'll have a supernova, and the supernova will fling off its material in a spherically oriented distribution, of course. So you have a supernova. This is an example of a famous planetary nebula. You notice that in a planetary nebula, at the very center, you will have left either a white dwarf or a white dwarf in a binary system. But of course, at the end of a planetary nebula, you'll also always have a white dwarf. This is a composite picture of various different planetary nebula as viewed by various telescopes. This is an example of Cassiopeia, one of the most famous supernova remnants. And this is a composite of various different supernova remnants. You'll notice both supernova and planetary nebula will have a remaining object at the center, and the material will have been shot out in a spherically distributed distribution, obviously. And if you took a picture of the same supernova remnant over a period of decades, it will look different, because this nebula will be expanding over decades and will slowly dissipate and expand. For that matter, H2 nebula are also very transient, because once the stars form, they are in very intense solar winds, right away start to blow away the H2 nebula. And additionally, a little bit down the line, you're going to start to get supernovas occurring, which are going to blast the area and wipe away the original cloud from which the stars were born. So you see there's a constant cycle going on, where dust and gas converts to stars. The stars convert the gas into the higher elements. When they come to their end, they redistribute these dust and gas back into the solar interstellar media, enriched, of course, with metals, because every star will make more and more metals. Still, the percentage of metals in the stars is only going to be a tiny amount, 1-2%. So nebulae, stars, very important. Hope you enjoyed this presentation. I'm Romeo Bruni, and this is the Astronomy Channel. See you next time.